Hello everyone, this is Parag and today we are discuss about design of singly reinforced beam. Here a numerical based on a designer a simple example of the design of simply supported RCC beam. Okay, for a span of 4.2 meter, the beam is subjected to the superimposed load of 20 kilonewton per meter. Use M20 grade of concrete with Fe415 steel. Now here one diagrammatical representation showing the width, depth of the beam, and here a simply supported beam diagram having the length showing 4.2 meter and superimposed load of 20 kilonewton per meter is shown in the figure. Now we have to determine the AST, that means the steel provided in the uh, beam, okay, with the proper cover, clear cover, and the proper size, sorry, what can I say, proper dimension of the steel with the number of bars. Now we go for the first of all, we solve this numerical by step. So first step is to determine to trial dimension. We have to first assume the B as a 230 mm because the wall thickness is normally, so beam thickness is normally 230 mm we consider normally. Now here with D, capital D is considered L by 10 relation because it is simply supported. If it is another cantilever or a continuous, so we get the another relation. Now we get here the trial as a dimension as a B and D. After that we go for the load calculation. Okay, we have to go for the load calculation. That means we have to calculate dead load, live load, floor load. If the floor load is given in the numerical, then you have to consider it. If it is not given, then there is no need to add in the load calculation. You have to first calculate the dead load and then you have to calculate your the live load is given in the numerical. Okay, live load is here 20 kilonewton per meter. Now dead load is B into D into gamma. Okay, B is your 0.23 as given in the assumed dimension. D is also, and gamma is here. Now by adding dead load plus live load, it is your total load, that is W. Okay, so 22.415. Now this is your working load. Okay, you have to multiply working load to make it factor load, so you have to multiply 22.415 by 1.5, so you get this factor load. Now we are using from this step working factor load, not a working load. So next, by determination of the load calculation, you have to determine the maximum bending moment. Okay, mu wu L square by 8. Okay, so you get the maximum bending moment by this formula is 74.137. Okay, after all, next step is check for a deflection. This mu limiting equals to m. Okay, this relation is given in the one box. This value is we have to calculate it. Introduction to limit state method, I provide one box where all the relation for the check for deflection, design of steel, this relation also, these both relation are provided in that box. Okay, so watch it out, the introduction to limit state method page in my web page. So here the check for a depth, mu limiting equals to mu, this relation is there. Because of this relation we get the actual value of the D, which is required value. Okay, but we consider the capital D as a 420. Okay, we are assuming it. Now from 420 I minus the 40 as a clear cover. We provide clear cover because we delay the rusting of the, we don't require that means we delay the rusting of the steel. Okay, so that's why we are provided 40 clear cover. So I make minus 420 minus 40 from the 420, so we get 380. Here required is 341.6, but we get 380, so we provide the size of a beam as capital D as depth is 420. Now comparing both the values, same what I say to 430, 341 is less than 380, so it is same. This value is same. So we provide the beam size is as 230 mm by 420, B by D. Okay. Now my next step is to determine the design of steel. Okay. So this relation is also given in the that table. XU, you have to calculate this. XU give the relation in the form of the AST. Now put this relation in these mu relation here, and after all you get the value of AST. Okay, you know the value of mu here, this one value is put here, and after that you get the value of AST. Again, this is one step. Now here is a standard formula for determination of the steel. which is given by AST equals to 0.5 FCK upon Fy in bracket 1 minus under root of 1 minus 4.6 mu upon FCK BD square to B into D. Actually, during the solving the problem, this formula by we put all the values, but sometimes in some calculators the value is not find out because we are not providing the proper brackets. Providing the proper brackets gives the proper exact value. Okay, because this is a very long relation, a long relation with the AST, so we have to provide the all brackets very properly to get the exact value. Okay, now we get these two value, 638 and 636.536. Okay, after that we require to calculate the minimum AST and maximum AST. Why I've determined these two values? Because when I find out the some minimum AST and maximum AST, I put the value of AST, this I calculated here, and after of that I find out the relation what I done here. Okay, this value is required and this is safe. Similarly with AST, if my minimum AST and maximum AST, this value lies between the minimum and maximum AST, so my this value is safer. Okay, so we go for the next slide. Here we check for the minimum and maximum still. Now according to IS 456 2000, along page number 47, the minimum and maximum relation is to be provided. Okay, you have to go with this AST minimum and AST maximum relation. So you get the value of AST minimum, you put the value of B into D here, Fy 0.85 is as it is, and AST we have to calculate it. Similar is a 4% of AG, B into D. Okay, so we make the relation. Okay, 386. So this value is we from that to mu and AST formula we take the minimum AST. So this one is from that two value. So we take this value, it is safe value. Now I wanted to provide 3 bars in the beam, right? So I I wanted to provide 3 bars in the beam, but what exact size of that beam? Sorry, the exact bar of that provided 3 bars I wanted to provide it. So here a formula to determine the bar dimension, steel bar dimension, which I wanted to provide it in the beam. So you know the value of AST, this one, you number of bars. If you wanted to provide it 4 bars, 2 bars, here the number of bar is placed, pi by 4 is same, 5 square, that means the diameter you have to determine. So you get 16.43. Okay, such a bar dimension is not provided, not available in the market. So 18 mm5 we get a round off here, and we provided such a dimension, such a bar dimension, bar diameter in the beam. After that, after this completion, we have to check for the beam, that means detailing diagram. Okay, detailing diagram, a diagram is like that: B, D, stirrups, beam, and this one is a 3 bars of 318 mm diameter. So this is what a very basic numerical to understand what is exactly design of beam. Okay, so thank you, and if you wanted this all notes, then just find out, go to my website, and there at the bottom this all the photocopies are available. So please download it and keep watching, keep learning. Thank you.